In this lesson here, we're going to take a look at using trig ratios to solve for a missing angle. We're going to go over some basics of just looking at triangles and how we understand the triangles and how we label the triangles. And then it's going to move more into how do we actually solve using our trig ratios. So I'm going to start off with a right angle triangle, which you may or may not have seen in the past. We're going to look at like Pythagorean theorem and the way that we can solve for a specific side. And that's something that we've probably done in the past. Before we start looking at angles, we're going to start looking at sides and how we deal with that. So for a right angle triangle, Pythagorean theorem can be used to find a missing side. As long as we know two of the sides, we can find the third one using Pythagorean theorem. Now, when we have an angle involved, so something like this here, Pythagorean theorem doesn't help us anymore. So we kind of have to get rid of it. It's not something that we're going to use anymore. We now need to use something different so we can solve for what is this angle measure, or we use the angle measure in order to solve for a specific side. And this is where our trig ratios are going to come in. And so let's take a look at how we're going to use them. So when an angle is involved, different equations, and we're going to use ratios in this case here, are needed to find the angle measure or side length of a specific triangle. In this lesson here, we're going to look specifically at right angle triangles, but we can move on and use these for different triangles as well and more complex ones as we get more and more comfortable with how to use these ratios. So we're also going to need a different labeling system in order to solve these types of problems. A, B, and C are no longer going to be used. Okay, you can still use them for Pythagorean theorem, but we're not going to use them when we're going to talk about trig ratios. So let's take a look at how are we going to do this. First of all, we're going to look at the C side. Now, C is a very specific side of our triangle. Okay, you may already know, and you can see on the screen there, is that we're going to call this our hypotenuse. So we're going to change that to hypotenuse, which represents the longest side of the triangle. Okay. Now, for the sake of simplicity, I'm going to usually simplify this and just leave it as HYP. It's going to represent the hypotenuse. And the hypotenuse is always the side that is the longest side and the one that is across from the right angle. So this is our side that is not attached to the right angle. It's very important that we understand that. That is our hypotenuse. All right, moving on from there. We have our A and B sides. Okay, these are called legs of the triangle, and they are attached to the right angle. You'll notice there that square, okay, it has two sides that make up that square. They make up that nice perpendicular corner. It's 90 degrees. A and B are our two legs of our triangle. So we're going to look at how can we label these ones. Well, the leg that is closest to the given angle. Now, given angle is going to be one of our acute angles. In the given triangle I have, it is on the top. Okay, it's that top angle. So if that's going to be our given or angle that we need to find, we call that the adjacent side. So we're going to switch that. Instead of A, we're going to call it adjacent. The A and the adjacent aren't necessarily related, by the way. And so in this case here, it is now adjacent. It is the one that is attached to the angle. Now, again, just like hypotenuse, I'm going to shorten this one a little bit. So let's just cut off the back and we're going to just say ADJ, and that's going to represent our adjacent side. Now I'm going to get a little bit more into which side is specifically the adjacent in a little bit when I get into the third side. So the final leg of our triangle, in this case it's B, okay, is the one that is not attached to the given angle. So you'll notice this one here is between it's attached to the 90 degree, but the angle it makes with the hypotenuse is not the given one or the one we're trying to find in this situation. This one is not adjacent to the angle, it is on the opposite side. And so we're going to switch this to the opposite. Okay. Now again, just like the other ones, I'm going to shorten it a little bit to make it simpler to read. And this is now our opposite side. So we have our hypotenuse, which again is our longest side, and that one is always the longest side no matter what. And we have our adjacent and opposite sides, which are related to the angle that is given or the angle that we are trying to find. And it's very important that we know which angle that is. All right, so you'll notice here I switched the question mark to a theta symbol. Theta is a Greek letter. We use it as a representation of a missing angle. And so that's what we're going to kind of use as the angle that we are trying to find or are given. Now, like I mentioned, the opposite and adjacent sides are determined by the given angle. Okay, the given angle there is theta. We don't know what the measure is right now, but that's the one that's given or we're trying to find. And so our opposite and adjacent are based on that. Now, if we were to also change it, so let's say we move this angle over here, okay, right there, you'll notice that the hypotenuse is not going to change. Okay, that part doesn't change. But the opposite and adjacent sides are going to flip because now the adjacent side is the bottom because the angle is on the bottom. The opposite side is now on the side because it is away from the angle that's given. So it's important that we understand that and are able to label our triangles exactly like that. All right, let's flip it back to the way it was. How we're going to solve for this angle measure. Now, in the past, you may have used a protractor. You'll put it up there. You'll figure out, oh, it's exactly 62 degrees. We're not going to do that in this case because we want to be able to solve it using the data that we are given. The data we are given is going to be 2 of our sides. 2 out of the 3 sides will be given, and based on that, we can then figure out what is the missing side. So, to solve for the measure of an angle, ratios are used to compare 2 of the sides of our triangle. So you need to know 2 of the sides in order to figure out the angle. There are 3 ratios that we're going to commonly use, and in this video here, this lesson, I'm only going to show you one, and then you can watch the second video, and we'll take a look at how to find the other 2 as well, even though they're very closely related, but we're going to start looking at one specifically today. The first ratio that we're going to look at here is called the tangent ratio, also known as tan. Okay, so it's shortened to tan just because tangent is really long and it's nice to write out something a little shorter. This ratio here, it relates or it uses the opposite and adjacent sides of the triangle to create a ratio which compares the two. So the opposite sides would be the 2 legs, and the tangent is the operation which converts the angle into the ratio. So we have a ratio which is given to compare the 2 sides, and the tangent operation changes the angle measure, which is related to those 2 sides, into the angle into the ratio. And we're often going to use it to go backwards as well. All right, the tangent ratio looks like this here. Now, you won't necessarily have to memorize this as it's something that will usually be given on a formula page, but tangent of the angle, okay, so we're using a function on the angle, whatever that number is equal to the same thing as the opposite side divided by the adjacent side. So if we take the tangent of the angle, it is exactly the same as if we divide the opposite side by the adjacent side. And given this knowledge and this function, we can then solve for specific angles in a triangle. Or what we'll find later on is we can find a side for it as well. All right, so first thing that I'm going to do is I want you to grab your calculator. Yeah, you need your calculator, okay? Super important to have. Let's see if I can find mine here. Okay, I've got my calculator right here. I'm going to show you some stuff on it as well. But there's our calculator, and I'd like you to find the tan button. It's not the button that gives you a tan. Nuh-uh, that's not going to happen. Now we got to find the tan button, okay? So here's my calculator. I took a picture of it. It's exactly this one right here. Great Casio. I don't know if that's important for you or not, but I really enjoy it. There's a tan button on here, okay? T-A-N, and it will be on every single scientific calculator. If you need, here I'll zoom it in a little bit. There we go. All right, okay. There we go. Now we can see our tan button, okay? You can see it. Oh, let's go that way. Yeah, got to figure out the way my camera is, okay? It's over there, okay? We can see it on there. Make sure you find that. It's important that we know where that tan button is. Got it? Awesome. Okay, let's move on. I want you to calculate tan of 25. Now, depending on your calculator, we're going to have to figure out how to use it because some calculators work a little different than others. And so make sure that you're getting the same answer as me before you move forward. If you don't get the same answer, pause it, pause the video, and then let's go make sure that you're getting the same answer. So on my calculator, what I'm going to do here, okay, and again, you aren't really able to see it at all in the in there, but I'm going to type in tan. So my first thing is 10, and then 25, and then I'm going to hit equals. So try that on your calculator. You should get a value of 0.466307654. Sorry, 658. And then there'll be some more decimal places there as well. It continues on and on and on and on forever. I hope you got that. If you didn't get that, try it again. If you're getting some different number, you might have your calculator in the wrong setting. Okay, there is another one. If you take a look on the top of your screen, there should be a DEG or just a little D in a square. My calculator has a little D. Other ones I've seen have a DEG. It represents that you're in degrees. If you're unsure of where you're in, please ask somebody else who has gone through these kinds of courses before. Maybe a trusted adult, maybe your teacher. If I'm your teacher, you can ask me as well. And we'll make sure that your calculator is in degrees, because then it'll give us our proper answers for our tan ratio. So hopefully you're able to get this. And if not, please ask somebody before you're moving forward in this calculation here. Okay, so tan of 25 will give us this ratio. Now, what we know about this ratio as well is that if we take the opposite and adjacent sides of our triangle, it's good, and divide them, it's going to give us 0.466307568, and then more decimal places afterwards as well. All right, so let's take a look at this triangle, and we're going to look at how we can come up with the tangent ratio as well. So let's determine the tangent ratio of this following angle. Well, first of all, we don't know what the angle is. It's theta. We're not given this angle. So therefore, we're going to have to use the opposite and adjacent sides to determine what the tangent ratio is for this angle. Well, step one, and this is going to be step one for every single right angle triangle that you get in this, whenever you're doing a right angle triangle problem, is you need to label the sides. All right, so we have the hypotenuse is the longest side, the adjacent being that upright piece because it is beside the angle, and then opposite being the other one, being 12, because it's not touching that given angle. The opposite is 12, the adjacent is 5. Therefore, we can plug those into our ratio, and tangent of our angle, which again, we don't know the angle, but tangent of that angle would give us 2.4 or 12 over 5. So this is how we're going to do this example or this type of question when we're coming up with the ratio. We're going to jump into some examples here, and let's just get to some examples. And so in these examples, gladly try to solve them first, and then pause the video as you're going, and then see if you're getting the same answer that I am, and then move on to the next one. And always make sure you're trying to get the same answer. Again, if you're getting wrong answers, it may be the way you're typing in your tangent ratio, or it might be that your calculator is in radians or gradients, which are two other ways of finding degrees. It needs to be in degrees. Radians and gradients are two other ways of finding a measure of an angle. Degrees is the original way, the one that we usually use. So make sure your calculator is that way. All right, example number 1, we want to show the tangent ratio for the given angle. Now, often I would ask you to draw out the diagram and label the sides. If you're doing this just on your own, you don't necessarily need to. But what is the tangent ratio? All right, the tangent ratio deals with this right here. Tangent of the angle is equal to opposite over adjacent. So because of this, we have to make sure we label the sides. Okay, there we go. Hopefully you have opposite, adjacent, and hypotenuse the same way I do. Remember that now in this case, the angle is, we're looking at angle W. Okay, that's the theta we're given there. And so 15 is the adjacent and 8 is the opposite. It's all based on where that angle is. Plug those values in. 8 divided by 15, our tangent ratio is 0.53. Okay, so there's 0.53. Let's try this one. Okay, we're looking at angle H. Can we solve for the tangent ratio of angle H? Of course we can. Okay, tangent of theta is equal to opposite over adjacent. Label our triangle. Opposite is 35 this time, adjacent is 12 because it's right beside the angle. Plug those in and we should get a tangent ratio of 2.91, and 6 is repeating apparently. So that's going to be our value there. All right, let's try another one. Tangent ratio. Okay, first of all, where's our angle? Well, it's on the bottom there, it's M. So we're going to label our sides as such. We have our adjacent on the bottom there, 63. Opposite is 60, and the hypotenuse is 87. And our tangent ratio will be 0.952. Are you getting this? Yeah? Awesome. Okay, so now here's the next piece. What's the angle measure? All right, we've got the ratio, and that's kind of step one. Step one is to be able to get the ratio. Step two now is going to be, can we find the angle measure? What is that angle? And yes, let's get the protractor, put it up there. No, let's do this calculating. Let's calculate the way we can do it because we have the tools to do that. We need to isolate theta. Okay, we need to isolate our angle in order to figure out what our value is. And we're going to use the ratio to do that, and we're going to use tan to do that as well. First things first, we need to get theta by itself, which means we need to remove the tan function from there. Now, if you've hopefully done some algebra in the past and looking at simplifying and isolating variables, to isolate that, we have to do the opposite of tan. Oh boy, well, you just learned tan. What's the opposite of tan? Well, it's taking the tan off, right? Oh no, that's not the way we're doing here. We need to remove tan with the inverse of tan, and that's what we're going to call it, the inverse of tan. Now we're going to apply the inverse of tan to both sides. And if you take a look at your calculator again, okay, on your calculator, you're going to see right above the tan function there. I know you can't see it in mine, and I apologize for that, but right above your tangent button is a tan -1. And that is the button which does the opposite of tan. Okay, so it takes the ratio and changes it back into the angle. And you'll often have to hit your shift or second function key in order to get that one there. So when we do this, all right, this is going to cancel out because tan and negative tan cancel each other out. And we're going to get something like this to find the angle. Inverse tan of the ratio. And I'm going to leave the ratio as a fraction so that it is as accurate as possible instead of rounding the decimal. All right. We could also write it like this here as well, the decimal, but I like putting it as the fraction. All right, let's solve for this here, okay? So we have this. How do we solve for it? Well, in your calculators, okay? Two different ways to do it, and I'll go through both. First one is to have it in the brackets. So you can type in, and I'll kind of go through here. I'm going to do tan -1. Now you might be able to see it there, maybe. All right, okay. Just checking my camera, okay. Tan -1, and then in brackets, I'm going to do 60 divided by 63, close brackets, okay. So I just finished off with the closed brackets there. And then when I hit equals, it's going to give me the angle. And in this case here, it's 43.60 degrees or 44 degrees. You can do the same thing with just the decimal as well. Plug that in. That works too. Or the final thing that you might do is you might do the division first. Okay, so you'll do 60 divided by 63, get your answer. And then, because your answer is usually in your calculator that way, you can do second function of tan and hit equals again, or you might not have to hit equals, and you should get that one as well. If you're having trouble using your calculator, please come and ask either your teacher, me if I'm your teacher, or somebody who might know how to use your calculator to figure out what is the best way for your calculation. All right, let's try another example here. Again, pause the video and start it back up once you think you got your answer. But we want to find angle W again. This is a previous one that we had. So we are going to, again, label. And we know that our opposite is 8 and our adjacent is 15. So we plug that into our function. And once we know that, we should be able to get an angle of about 28.07 degrees. And for the sake of my class or my students, I will say round to the nearest degree. Okay, that's as close as we need. Show your answer and then round to the nearest degree. Let's try another one here. What is angle H? Again, reusing some of them from the previous examples. Okay, label. First step, always label, always label. Next step, plug in your opposite divided by your adjacent with the inverse tan in there, or a second function of tan. And you should get an angle of about 71.08 or rounded to 71 degrees. All right, Now we're cruising. Let's do the next one here. Okay, let's calculate the measure of this angle. We are looking for angle B. And so angle B, we first again need to label hypotenuse, opposite, and adjacent. Now you might be saying, why do we need to label the hypotenuse? As we move farther along, we need to make sure we know which one is our hypotenuse there. Tan of those and round to roughly about 41 degrees. You should get 41.11 degrees. Now, that's all the examples I have for this one. Gladly take a look at the next video in order to see the other functions that we use as well. But this is, again, a really good start on how to use our tan function in order to solve for angles. All the best as you keep practicing.